So, last video we have an understanding of the multivariate analysis. Let's understand Bayesian modeling, inference, and Bayesian network in this section. So, what's really the Bayesian modeling is all? A Bayesian model is a statistical model where you use probability to represent all uncertainty within the model, both the uncertainty regarding the output, but also the uncertainty regarding the input, like a parameter to the models. A statistical model can be seen as procedure story describing how some data came to be. A Bayesian model is a statistical model where you use probability to represent all uncertainty within the model, both the uncertainty regarding the output, but also the uncertainty regarding the input and the parameters to the models. So here we are taking the uncertainty within the model and within the model as well as input and output as well. We are gripping the certainty in this type of model. That means that most other statistical modes can be cast into a Bayesian model, but by modifying them to be using a probability everywhere. This is especially true for models that rely on maximum likelihood. As maximum likelihood model fitting is a strict subset to the Bayesian model fitting. Different Bayesian models can be evaluated and compared in several ways. The fit of Bayesian model to data can be assessed using posterior and prior predictive checks. When evaluating potential replication involving new parameter value or more generally mixed checks for the hierarchical models, the challenge is to estimate predictive model accuracy, correcting for the bias inherent in evaluating a model's prediction of the data that were used to fit it. Bayesian inference is a method of statistical inference. Bayes' theorem is used to update the probability for the hypothesis as more evidence or information become available. Bayesian inference is an important technique in statistics, especially in mathematical statistics. Bayesian updating is a particular important in the dynamic analysis of a sequence of data. Bayesian inference has found application in a wide range of activities, including science, engineering, philosophy, medicine, sport, and law. In the philosophy of decision theory, Bayesian inference is closely related to a subjective probability, often called Bayesian probability. For understanding what really the Bayesian probability is, let's move towards what is really the probability is. Probability means possibility. It is the branch of mathematics that deals with the occurrence of the random. The value is expressed from 0 to 1. Probability has been introduced in maths to predict how likely events are to happen. The meaning of probability is basically the extent to which something is likely to happen. This is the basic probability theory, which is also used in probability distribution, where you will learn the possibility of outcomes for a random experiment. Find the probability of a single event to occur. First, we should know the total number of possible outcomes. Probability is a measure of the likelihood of an event to occur. Any events cannot be predicted with total certainty. You can predict only the chance of an event to occur. However, how likely they are to happen using probability can range it into from 0 to 1, where 0 means the event to be an impossible one and 1 indicates a certainty. Probability for class 10 is an important topic for the student, which explains all the basic concepts of the topic. Probability of all events is sample space next to 10. We got this concept in class 10. Thing is how the Bayesian concept is related to this code is defined in the class 10 only. Now, let's take an example. When we toss a coin, either we get head or tail. Only two possible outcomes are possible. But if we toss 2 coins in the air, there should be 3 possibilities of events to occur, such as both coins show head or both show tails, or one shows head, one tail. That is head, tail, tail. So how we'll get a formula of the probability? The probability formula is defined as the probability of event to happen is equal to the ratio of the number of favorable outcomes and the total number of outcomes. Probability of event to happen, we need to go for the formula. Probability of event is equal to number of favorable outcomes divided by total number of. Sometimes a student gets mistaken for favorable outcomes with desired outcome. This is basic formula. There are some more formulas for different situations or examples and solutions. There are 6 pillows. In a bed, 3 are red, 2 are yellow, and 1 is pink. What is the probability of the pinking a yellow pillow? The probability is equal to the number of yellow pillows in bed divided by the total number of pillows, 2 by 6. So it is 2 by 6, and the answer will be 1. Now let's understand about the conditional probability. Imagine a student who takes leave from his school twice a week, including Sunday. If it is known that he will be absent for his school on Tuesday, then what are the chances that he will also take a leave on the Saturday week? If it is observed that is a condition or the occurrence of one event affects the happening of the following, these cases of probability are known as the conditional probability. What is the conditional probability definition? The probability of occurrences of any event A when another event B in relation to A has already occurred, known as the conditional probability. It's depicted by the P probability A by B. What is conditional probability? As depicted by above diagram, sample space is given by S, and there are 2 events A and B. In a situation where B has already occurred, then our sample space has naturally get reduced to B, because now the chances of occurrence of A will be like inside B. As we have to figure out the chances of occurrence of event A, only postponed to both A and B cannot represent the probability of occurrence of A when B has already occurred. Common force of the event is depicted by the intersection of the both events A and B, that is A intersection B. This explains the concepts of the conditional probability problem, occurrences of any event when another event is related to the already occurred. Now let's understand the formula within that. Mathematically, this can be represented as the P A probability of occurrence of A of given B has occurred, and A intersection B is the number of elements common to both A and B. When NB is the number of elements in B cannot be equal to 0, and N represents the total number of elements in sample is fixed. PAB represents the probability of occurrence of A given B has occurred, and A intersection B and N B N. Since N A intersection B divided by N and N B by N denotes the ratio of the number of the favorable outcome to the total number of outcomes. Therefore, this indicates the probability. Therefore, A intersection B by N can be written as a P intersection B and NB by N is P probability of the B. Finally, we will get a like TA probability of B going of the B is equal to P intersection B divided by B, and that is the probability P. Therefore, PA intersection B is equal to probability of the occurrence of the B, probability of A occurrence of the A if P is not equal to 0, and P probability of occurrence of the A, probability of occurrence of the already occurrence of the B, which guide the A, and if PA is not equal to 0. Similarly, the probability of occurrence of B when A has already occurred is given by P probability A and B intersection A, B intersection A divided by the probability intersection A. To have better insight, let us practice some conditional probability examples. Let E and F be event of the same sample space of experiment. Then we have a PSF is equal to PFF is equal to property 2. If A and B are any 2 events of a sample space S and F is an event of the S such that PF is not equal to 0, then A union B, A union B for the F, PA for the F, PB for the F minus PAV and for the F. And third property is PA dash B is equal to 1 minus complementary PA complementary B is equal to 1 minus PAB. So let's understand with an example. Two dice are thrown simultaneously and the sum of the numbers obtained in the found to be B7. What is the probability that the 3 has appeared at least once? The sample space S would consist of all the numbers possibly by the combination of the two dice. Therefore, S consists of the 6 cross 6 events. A indicates that the combination in this 3 has happened at least once. And B indicates that the combination of the set numbers is sum of set. So these are the sample spaces C1, 3, 2, 3, 3, 3, 4. 3, 5, 3, 6, 1, 3, 2, 3, 3, 4, 3, 5, 3, and 6, 3. Where 3 has appeared, and the combination is 7 is like 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. The B occurrence of A is 11 by 26, and the B occurrence is 6 by 2. Intersection is 2. And the probability of the intersection of B is a 2 by 26. By applying the formula, we will get the result 30. This is how it works. Now let's move about to naive Bayes classifier. This model is based on the Bayesian theorem, the key assumption that each feature is conditionally independent of the other features. Each feature has the same weight. This is the formula. This is Ex is the posterior probability, Px is the likelihood, Pc is the classic prior probability, and here it is the predictor prior probability. From this way, we get this posterior probability is equal to P C and cross condition C and to cross Px and C cross PC. And here we classify with the help of this introduction of the name classifier, we will get the Bayes theorem. If you want to classify an email as spam or one or not, if you want to classify an email whether it's a spam or ham, then we go like that. P classifier C classifier X is equal to P, Y is equal to 1, email is equal to X. And for this, we actually made this diagram. Understanding, let's move on. We just take for actual value and predicted values and classified it to the positive and negatives. And we have two positive, false positive, false negative, two negative, and actually we get this by an experiment by putting this formula. If you want to classify an email as spam, then it will put 1, and if it's not, it will put 0. PCX PY is equal to 1, then email is X, and PX is this C and cross PC is equal to P, X cross Y is equal to 1 cross P is equal to 1. P email X Y is equal to X Y Y is equal to 1, P Y is equal to 1, plus P email X Y Y is equal to 0 cross P Y is equal to 0. Then how it is calculated, how we get a confusion matrix. See, predicting if a customer will return a positive or negative, we can use following matrix for the accuracy, specificity, sensitivity, and precision. Accuracy, specificity, and sensitivity of precision. And for this, we use the formula: this 2 positive plus 2 negative divided by 2 positive false negative plus false positive plus 2 negative. Out of the all possible data, what proportional are correctly classified by our model? That is accuracy. How will get a specificity? 2 negative divided by the false positive plus 2 negative. Out of all customers that did not return negative, what proportion is correctly classified by our model? Model accuracy in predicting negatives. Sensitivity or recall: 2 positive divided by 2 positive plus false negative. Out of the all customers that returned positive, what proportion was correctly classified by our model? Model accuracy in predicting positives. Precision is equal to 2 positive divided by 2 positive plus false positive. Out of all customers that were predicted to return positive, what proportion actually returned? So in our example, we will prioritize how accurate our model is correctly classified whether if a customer will return. Thus, it makes sense for us to optimize precision and recourse score, but there is a trade-off between the two metrics. Now, we got an introduction of really the Bayes matrix is what conditional probability what the matrix is. Let's get terminology of the Bayesian network as well. Bayesian network are a type of probabilistic graphical model that can be used to build models from data and or expert opinion. They can be used for the wide range of the tasks, including prediction, anomaly detection, diagnostics, automated insights, reasoning time series predictions, and which make uncertainty. Here one shows capabilities in terms of the four user analytics disciplines: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive. This is the graph between precision and the record: 60% cutoff, 30% cutoff, and 5% cutoff. It's a graph. This is known as the ROC curve. Based on the some matrix mentioned above, we can derive actually the receiver operating characteristics ROC curve as an evaluation matrix. The ROC curve visualizes how well the biometric classifier distinguishes between the two classes. AUC simply means the area under the ROC curve. The higher the AUC closer to 1, the better the diagnostic ability of our model. Whatever they close to the 1, it is the model is a highly diagnostic. So below the matrix of the ROC curve, two positive rate by recall by sensitivity, we get it by the formula two positive variable, two positive plus false negative, and two negative rate by specificity, we same formula T, two negative by two negative plus one positive. So Bayesian network are the types of probabilistic graphical model that can be used to build models from data. We always use data. We always use data for predicting. And they can be used for a wide range of tasks, including the prediction, anomaly detection, diagnostic, automated insights, reasoning, time series predictions, and decision making and uncertainty. Figure 1 below shows this capability in terms of the four major analytic disciplines: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive. These are the following analytics: descriptive, diagnostic, predictive, and prescriptive. Examples are the descriptive analytics, we have automated insights, class patterns, and multivariate analysis. Diagnostic, we have value confirmation, reasoning, troubleshooting, tracing anomalies, predictive, supervised or unsupervised, time series, latent variables. Next is prescriptive, decision automation, cost-based decision making, decision support, decision making under uncertainty. Figure 1: descriptive, diagnostic, predictive, and prescriptive analysis with Bayesian method. They are commonly referred as the bias nets, belief networks, and sometimes causal networks. We have some terminologies like probabilistic. Bayesian network are probabilistic because they are built from probability distribution. Also use the laws of probability for prediction and detection. For reasoning and diagnostic decisions making, uncertainty and time series predictions. Graphical. Bayesian network can be depicted graphically as shown in figure 2, which shows the well-known ACR network. Although visualizing the structure of a Bayesian network is optional, it is a great way to understand a model. This is how some tuberculosis patient has. Tuberculosis or cancer, how it will be designed. Like this. If I'm going to visit the ACR, true or false, then person can be a tuberculosis. How can we determine if it can be tuberculosis or cancer? We get it from the X-ray result or dyspnea. Okay, if a person is smoker, then he should have maybe that has a lung cancer, which covers the cancer. If a person is smoker, then has a bronchitis. Let's go for the test. So Bayesian network is a graph, simple Bayesian network, known as Bayesian network. And Bayesian network is a graph which is made up of the nodes and directed links between them. Nodes in many Bayesian network, each node represents a variable, such as height, age, or gender. A variable might be discrete, such as gender is equal to male, or might be a continuous, such as someone's age. Bayesian server, each node can contain multiple variables. We call nodes with more than one variables multivariable nodes. The nodes and links form the structure of the Bayesian network. We call this structure is specification. Bias server supports both discrete and continuous variables. A discrete variable is one with a set of mutual exclusive states such as gender, female, male. Gender, female. What is continuous? Bias server support continuous variables with conditional linear Gaussian distribution (CLD). This means that the continuous distribution can depend on each other or multivariate. It can also depend on one or more discrete variables. Links. Links are added between nodes to indicate that one node directly influences the other. When a link does not exist between two nodes, it does not mean that they are completely independent, as they may be connected via the node other nodes. They may be, however, become the dependent on the independent depending on evidence that is set on the other nodes. Although links in the Bayesian network are directed, information can flow both ways according to the strict rules described later. Structured learning. Bayesian server includes a structured learning algorithm for the Bayesian network, which can automatically determine the required links from the data. Note that the structured learning is often not required, as there are many well-known structures that can solve many problems. Next is the feature selection. Bayesian server supports the feature selection algorithm, which can help determine which variables are most likely to influence another. This can be helpful when determining the structure of model. Another useful technique is to make useful use of the later variables to automatically extract features as part of the model. Directed acyclic graph (DAG). A Bayesian network is a type of graph called a directed acyclic graph or DAG. A DAG is a graph with directed links and one which contains more directed cycles. Directed cycles in a graph is a path starting and ending at the same node, where the path taken can only be along the direction of the links. What are the notations? At this point, it is useful to use simple mathematical notation for the variables and probability distributions. Variables are represented with uppercase S and the values with the lower cases. If A is equal to A, we can say A has been instantiated. The set of variables is denoted by bold upper letter X and the particular instantiation by bold lowercase x. For example, X represents the variables A, B, C, then X is the instantiation A, B, C. The number of the variables X is denoted by mod X. The number of possible states of a discrete variable mod A is denoted by mod. The denotation Px is used to refer to the parent of X in graph. For example, to dyspnea or tuberculosis or cancer or bronchitis. P to denote the probability of it. P is P to denote the condition probability of A. What is then inferences on? Inference is a process of calculating a probability distribution of interest is P, K, P. The term inference and queries are used using following terms are all forms of predictions focused around defining outputs from diagnostics, inferring inputs from the same prediction. Supervised analytics. Inference is used to calculate the P or no common law. Decision making and content optimization and inference combined C. Okay. Example of the inference practice. Given number of signals which Caesar might over. How likely is the component which fail with the current state of the system? Given behavior of the two steps, how will they behave together for the next 5 steps? For this, we go for the algorithm. There are a large number of exact methods. Price server supports exact approximate interferences. Bayesian network, dynamic Bayesian network. Dynamic Bayesian network. Dynamic Bayesian network are taken as the most used for the modern times. They extend the concept of standard Bayesian network with time. In Bayes server, time has been a native part of the platform from day one, so you can even construct a probability distribution such as pxt is equal to 5 y z t. Once you have built a model, often the next step is to make a decision based on what. In order to make those decisions, costs are often involved. Doing this manually, there can be many different decisions to make cost to trade off against each other. Now, this uncertainty environment that is now an extension of the Bayesian method which handles decision making. What are the dynamic Bayesian networks? See, dynamic Bayesian network extends standard Bayesian network with the concept of time. This allows us to model time series of sequences. In fact, they can model complex multivariate time series, which same model of the differentiator disease of the behaviors in time series of create different in the different process. This is an example which should give us the dynamic price of that. What is autocross and partial correlation? Autocorrelation between a variable at different times. Cross correlation is correlation between the different time series. Partial correlation is the correlation between the same or different time series with the effect of the lower order correlation. This is how the things govern for the dynamic Bayesian network. In the next lecture, we will go for the multi-class classification, like machine learning algorithms that we can see in support vector machines.